Alright, in this section we're simplifying radicals. And what that means is we have something under a square root sign. A radical is just a square root symbol. And we have something under that square root symbol that we can't take a nice even square root of. So let's look at how to do this. We know that 56, one way we can do it, if we can't think of a nice even square root that will multiply to get 56, we can do a prime factorization. And so the way to do a prime factorization, or the way I do it, you write the number, kind of do an upside down division sign, and put the prime number that you want to divide by out front. And 2, as long as it's an even number, we'll start with 2. So 2 into 56 is 28. Now 28's even again, so we'll divide by 2 again and get 14. 14 will divide by 2, and that's 2 times 7. So all those numbers out here are prime numbers on the left, and that's what you want, the prime factorization. So now you put them in groups of 2 because it's a square root. They have to be the same number in a group. So I can't put the 2 and 7 in a group because they're not the same number. Now, what that tells me is that 56 is the same as 4 times 14. And I can take the square root of 4. See this group right here that I'm looking at right there. 2 times 2 is 4, so the square root of that is 2. And that number that you take the square root of comes in front of the radical. So that 2 would go in front of the radical. And then the numbers that you could not get multiplied or grouped into it, you would multiply those, but they were the numbers you couldn't put in a group of 2, stay under the radical, and that would be 14. And so this would be simplified to 2 times the square root of 14. And that would be your final answer for simplifying under the radical. For number 2, again, we'll do a prime factorization on the 324. It's even, so we divide by 2 and get 162. Divide by 2 again, 81. Well, now I find that I can take a nice even square root of 81. I know that one. That's 9 times 9. Well, let's group in groups of 2. I have 2 2's and 2 9's. The square root of each group is that number, because this is that group multiplies to be 4, this first group. Square root of that is 2 right here. The square root of 81, which is 9 times 9, is 9. Now, any numbers that I pull out in front, these would be numbers that went out in front of this radical. I can multiply those together. So 9 times 2 is 18. But look, there's nothing that I couldn't pair up in this prime factorization right here. I have 2 pairs. There's nothing left over. So that means that I could take a nice even square root of 324. If I happen to know my squares and square roots through 20, then you would know that without even having to think about it. So that's a good thing to memorize, your squares and square roots through 20. But your answer to 324, square root of 324, is 18. So even if you don't know that it's a nice even square root, you can discover it pretty easily. So 98, we're going to do a prime factorization, which is 2. And so that's going to be 9. So that tells me, if we want to look at this another way, that 98 is 49 times 2. And 49 is 7 times 7. So remember that, group them. That number comes in front. And we look here, square root of 49 is 7. So once we take the square root, it's in front of the square root symbol. And what's left underneath here that we couldn't put under, that we couldn't take out front, couldn't take a square root of, is the 2. And so from either of these methods, you can get 7 times the square root of 2 as your simplified answer for the square root of 98. Now, this one's a little different because you have 5 times, and so we can think about it like this. 5 times the square root of 300. Well, any 100 is kind of easy to do because we know that square root of 300 is the same as the square root of 100 times 3. And we can take the square root of 100. 10 times 10 is 100. So the square root of 300 would be the same as 10 times the square root of 3. So once we get it down that far, we've simplified the square root of 300. Now we just multiply it by 5. Now this 3 is not a 3. The 3 is the square root of 3. So we don't multiply the 5 by that. We only multiply the numbers in front. So 5 times 10 is 50 times the square root of 3. And so that's your final answer. Okay. Looking at the next two problems, this says solve using the square root method. And so this is another method that we're learning. We learned by factoring how to solve. Now we're going to learn by the square root method how to solve. And so the first thing to do is to move your constant over. So we're going to add 49 to both sides. Okay. And that's going to leave you with x squared equals 49. Now you're going to take the square root of both sides. And remember, when you have an even exponent here, when you take the square root of it, you need to put plus or minus in front of your answer. So the square root of x squared is x, and that equals plus or minus square root of 49, which is 7. That's a nice integer answer. They're not all going to be that way. Some of them you're going to have to simplify under the radical. But now we have our answer there. So x is plus 7 and x is 7 and negative 7. There's two answers there. So that is your answer for how to go about solving things using the square root method. Looking at number 6, it's the same thing. Take this number and add it across. So you're going to add 27 and add 27. So you have 3x squared equals 27. Now I don't want a number in front of this x squared. You want it just x squared. So we're going to divide by whatever number's in front of that. In this case a 3. That becomes 1x squared is equal to 9. Now once you get x squared equals some number, you square root both sides. And so we end up with x is equal to plus or minus 3. And that is your answer. So that's when you don't have that x term. In 10.1, at the end of this unit, we're going to learn how to complete the square to do this same thing. But right now, if there's no x term, you just use the square root method, and you can solve it this way. Alright, let's do a few more examples. Okay. Again, move the 48 over. So you have x squared is equal to 48. Square root both sides. So x is equal to plus or minus the square root of 48. Well, I can't take a nice even square root of 48. So this is where the simplifying under the radical comes into play. So we have 48 divided by 2 is 24, divided by 2 is 12, divided by 2 is 6, divided by 2 is 3. So all these numbers here are prime numbers. We've got our prime factorization, group them in groups of 2. So we have that 3 here that we couldn't put in a group. So that's what's going to stay under the radical. What comes out front of the radical? Well, you have to multiply the square root of those groups together. So the square root of this first group here is the square root of that group. 2 times 2 is 4. So the square root of that is a 2. And the square root of this group is also a 2. So you then multiply 2 times 2. These numbers that you put here in the front, you're going to multiply together. And that's what goes here in front of your radical. Okay. Looking at 9, we're going back to factoring completely. This is going back to review. Okay, factor completely. GCF first. So your GCF is going to be a 4. So you end up with 4 times 2x squared minus x minus 15. Now you have to see if you can factor that. Multiply a times c, and you get negative 30, and b is negative 1. So you have a plus answer and a minus. You're going to split that into your two numbers that you're going to find. One is plus and one is minus. And it's going to be negative 6 and positive 5 because I want them to add to be negative 1. So now we're going to have our 4 here for our final answer, but I'm not going to work with that right now. I'm just going to work with what's here in parentheses. So you have 2x squared. Instead of the negative x, I'm going to write negative 6x plus 5x and then minus 15. And again, this and this are the same. That negative 6 and 5 is only rewriting negative 1 in a different form. You're going to group, factor out your GCF from each group, which in the first group it's 2x. So when you divide by 2x, you get x minus 3. And from the second group, your greatest common factor is 5, which that division will give you x minus 3. So one of your factors are the numbers in front of the factors, which is 2x plus 5, and the other one is x minus 3. And since it didn't say solve, the instructions here clearly say factor, so this is the answer. I don't have to have a solution, I just factor, which means get two sets of parentheses. Now I left out number 8 for some reason, so let's go ahead and go back up and do that one. That's a solve. I know because there's an equal sign there that I wouldn't want to get an answer. So let's move it over. We have 10x squared. Well, first of all, we notice there's no x term, so that changes things. We're going to add 60. Add 60 to both sides. So this becomes 80. And then you have 10x squared. Divide by 10, because we remember we want just an x squared. So x squared is equal to 8. Well, 8 is 4 times 2. So when I take the square root, 8 is the same as 4 times 2, right? So if I take the square root of both sides, I have x is equal to plus or minus the square root of 4 times 2. And I can take the square root of 4, that comes out front, in front of the radical. The radical, again, is the square root symbol. So when I take the square root of 4, I end up with 2. And then the other 2 that I couldn't take the square root of has to stay underneath the square root sign. And so that would be your final answer. And again, that's two answers. A positive 2 times the square root of 2 and a negative 2 times the square root of 2. That's your two answers. One last one we're going to solve. This is a solve. Now, this again, since there's an x there, we're probably, at least not yet, you don't know yet how to solve that. You will. But right now, we're probably going to look at factoring or at factoring. Factoring or either probably by grouping. So we're going to bring everything across. So we're going to add 5x and subtract 4. So you have 6x squared plus 5x minus 4 equals 0. And remember, I moved all of that instead of the 6x squared because I want that to be, want the 6x squared to stay positive. There's no greatest common factor. So a times c is equal to negative 24, and b is equal to 5. So I have a positive factor and a negative number that's going to take the place of my middle term. Again, because that sign is negative, that's what tells me that piece of information. And 8 and 5 multiplied to be 24. 8 times 3, excuse me. Multiply times 24 and add to be 5, and I need to be positive 5, so it's going to be positive 8 and negative 3. So you replace the 5x, you have 6x squared minus 3x plus 8x minus 4 equals 0. Group them. Factor out your greatest common factor, which is 3x. And when you do that division, you have 2x minus 1 plus your greatest common factor there is going to be a 4 in the second set of parentheses. So when you do that division, you have 2x minus 1. And so your answer is 3x plus 4 times 2. That's not really your answer. 2x minus 1. That's your factorization. We're not in an answer yet because our instructions were solve. That means I have to figure out what x is. So that last step then is to say 3x plus 4 equals 0 and 2x minus 1 equals 0. And now you solve it. Subtract 4 from both sides, so you have 3x equals negative 4, and you divide by 3. So x is equal to negative 4/3. Here you have 2x equals 1 because I add 1 to both sides. And you divide by 2, so x is equal to 1/2. So negative 4/3 and 1/2 are our two answers that you're going to write if there's a solution. X equals negative 4/3 and 1/2. And those are your two answers. All right, that is 5-4.